All right, get ready because today we're going deep into the world of algorithms.
Yeah, algorithms, they're everywhere, even if we don't always think about them.
I know, right? I mean, think about it. Spotify recommending that perfect song or Google Maps getting you where you need to go the fastest way possible. Algorithms are behind so much.
And the crazy part is they've been around forever, long before computers, shaping the world in ways we don't even realize.
Oh, really? I never thought about that. So before computers, what were algorithms doing? Like, what did that even look like?
Well, think about ancient civilizations. They were already using algorithms to predict astronomical events or figure out the best ways to divide land, stuff like that.
Wow. So those early algorithms were more like step-by-step instructions, almost like a recipe, right, to solve a specific problem.
Exactly. And that core idea, that recipe idea, is still true today, even though things have gotten way more complex, especially with, the rise of computers.
I bet. Computers and algorithms, it's like they were made for each other. Computers love processing information fast and accurately.
They do. And speaking of a perfect pairing, there's this book, The Art of Computer Programming by Donald Knuth. Published in 1968, it's basically like the Bible of algorithms.
So that book kind of set the stage for how we think about and use algorithms in the computer age.
Absolutely. Knuth's work was super important in figuring out how to analyze and compare algorithms, especially when it comes to figuring out which ones are most efficient for different tasks.
I'm starting to get why that matters. Time is everything, especially for computers dealing with mountains of data.
You got it. Choosing the right algorithm can make the difference between something taking minutes or, hours or even days.
Right, efficiency is key. So
Mhm.
we've got all these algorithms out there, each one built to tackle a different problem. Are there ways to group them into like main categories to make sense of it all?
Totally. Think of it as a toolbox. Different tools for different jobs. One of the most basic categories, sorting algorithms.
Sorting, like organizing a music library by artist
Right.
or putting files on your computer in alphabetical order.
Exactly. It's about putting things in order. And you might think sorting simple, but there are a ton of different sorting algorithms, each with its own strengths and weaknesses.
So it's not as easy as just telling a computer, hey, sort this stuff.
Not quite. Some are faster for short lists, others are better for massive amounts of data. It's all about using the right tool for the job, right?
Makes sense. So what other tools are in this algorithm toolbox?
Well, you've got search algorithms. Think about finding a website on Google or a file on your computer. That's search algorithms in action.
I use Google every day, so I guess I'm using those algorithms all the time, even if I don't see how they work.
Exactly. And just like with sorting, there are lots of different search algorithms, each optimized for certain situations. Some are super fast at finding things in lists that are already in order, while others are better at going through data that's totally random.
It's starting to feel like learning a whole new language. Are there even more types of algorithms out there?
Oh, yeah. There are also graph algorithms, which are used for stuff like finding the shortest route on a map or understanding social networks. And then you've got randomized algorithms, which bring in a bit of chance. Like, think about shuffling your playlist. That's a randomized algorithm at work.
Wow, it's incredible how many different kinds of algorithms there are. It's like a whole world operating behind the scenes, shaping how everything works.
And we haven't even touched on the really cutting edge stuff yet, like machine learning. That's where things get really interesting.
I've heard so much about machine learning. It sounds almost like science fiction. Computers that can actually learn and get better over time.
It really is pretty amazing. These are algorithms that can analyze massive amounts of data, find patterns, and make predictions.
So those personalized recommendations you get on Netflix or Amazon, those are examples of machine learning.
You got it. And it goes way beyond that. Machine learning is being used for everything from self-driving cars to diagnosing medical conditions.
That's mind-blowing. But with all this algorithmic power, are there downsides? I mean, no technology is perfect, right?
You're absolutely right. Even the most advanced algorithms have their limits. One of the biggest challenges is that their quality depends entirely on the data they learn from.
So, like, if the data is bad or biased, the algorithm will have those same problems.
Exactly. It's like trying to build a house on a weak foundation. And then there's the problem of some problems just being super complex. Even the best algorithms can struggle to find the absolute best solution.
That makes sense. You can't expect algorithms to have all the answers, especially when dealing with real-world problems that are, messy and complicated.
Yeah. And that's where human judgment and thinking things through still really matters. We need to be aware of both the strengths and the limits of algorithms.
Okay, before we go too deep into the philosophy of all this, I want to clear up something that's always confused me.
Yeah.
What exactly is the difference between an algorithm and a heuristic? They seem kind of similar.
That's a great question, and it's a really important distinction. Think of an algorithm as a precise set of steps that's guaranteed to give you a specific result as long as you follow the steps correctly. Like a recipe. If you follow it exactly, you should get the same dish every time.
So algorithms are all about being precise and predictable.
Exactly. Heuristics, on the other hand, they're more like rules of thumb. They might work well a lot of the time, but they don't guarantee the best solution or even a correct solution every single time.
So like choosing a checkout line at the grocery store. You pick the one that looks the shortest, but you never know for sure if it'll be the fastest.
Perfect example. Algorithms are about certainty and finding the absolute best way to do something, while heuristics are more about making good guesses based on experience and intuition.
I'm starting to see the difference. It's like algorithms are the careful planners, and heuristics are the ones who can think on their feet and improvise.
Exactly. And both have their place. It just depends on the situation and how important it is to be perfectly precise.
This is making a lot more sense now.
Yeah.
We've covered so much already, the history of algorithms, machine learning, it's amazing. But I want to hear more about how all of this is actually used in different areas. What are some of the most exciting applications of algorithms in the real world?
Oh, there are so many. We could talk for hours. But let's start with one that's super relevant to all of us: online security.
Ooh, that's a big one. Keeping our online information safe is more important than ever.
It is, and that's where cryptography comes in. It's all about using algorithms to protect information, making it basically impossible for the wrong people to access it.
So when we make secure transactions online, that's all thanks to algorithms running in the background.
Exactly. Without cryptography, online banking, shopping, even just sending an email would be wide open to hackers. And speaking of money, algorithms are also playing a huge role in the world of finance.
I've heard about those algorithms that make super fast trades on the stock market. Is that what you mean?
Exactly. They analyze market data, find patterns, and make trades way faster than any human could. But it's not just about speed. Algorithms are also used to manage risk, find investment opportunities, and even detect fraud.
So they're like super-powered financial assistants, crunching numbers, and making recommendations based on levels of analysis that humans just can't match.
That's a great way to put it. And it goes beyond finance, too. Algorithms are changing healthcare, analyzing medical images, personalizing treatments, even developing new drugs.
It's incredible how much algorithms are shaping the world around us in almost every area you can think of.
And this is just the beginning. As algorithms keep evolving and becoming even more powerful, who knows what amazing things they'll be able to do in the future.
I'm definitely hooked on this algorithm adventure. I can't wait to dig deeper into some specific examples and see how all these invisible forces are shaping our lives in ways we probably never even imagined.
Algorithms are having a huge moment right now.
Yeah, they really are. It's like we've uncovered this whole secret layer of complexity that's powering, well, pretty much everything.
And the thing is, we're still pushing the boundaries of what algorithms can do. The advances in computing power over the past few decades have been insane.
Right, we were talking about that earlier. It's like giving these algorithmic chefs a way bigger and better kitchen to work in.
Exactly. And with more powerful computers, we can tackle problems that used to be impossible. We can analyze way more data, run super complicated simulations, even create totally new kinds of algorithms.
So it's not just about speeding up the algorithms we already have, it's about opening up whole new avenues for exploration.
Exactly. Think about it just a few decades ago. Self-driving cars or personalized medicine seemed like something out of a movie. But now, because of how far algorithms and computing power have come, those things are becoming real.
It really is amazing how much progress has been made. But what about the challenges that come with all this innovation? Are there any limits or roadblocks that researchers are running into?
Of course. Developing algorithms is this constant back and forth between, like, what we want to achieve and what's actually possible. One of the biggest challenges is just the sheer complexity of some problems. You might have an algorithm that looks great on paper, but if it takes years for a computer to run it and get results, it's not going to be very useful in the real world.
Right, it's like having a recipe for the most amazing cake ever, but it takes a whole week to bake it.
Exactly. So we're always searching for more efficient solutions, for finding those elegant ways to make algorithms run faster, even when dealing with tons of data. And then there's the whole issue of data quality, like we were discussing earlier. Algorithms are only as good as the data they learn from.
Like the saying, garbage in, garbage out.
Exactly. If the data is messed up, biased, incomplete, whatever, those problems are going to show up in the algorithm too. That's why cleaning up the data and getting it ready is so important before you even start designing the algorithm itself.
Sounds like there's a lot of careful prep work involved before you even get to the exciting part of actually building the algorithm.
Totally. It's kind of like building a house. You can't just start putting up walls if you don't have a strong foundation. Data is the foundation for any good algorithm.
Okay, so we've got these incredible algorithms doing all these amazing things, but I'm curious about the bigger picture too. How are algorithms changing society as a whole? Are there any big implications we should be thinking about?
That's a really important question. Algorithms are having a bigger and bigger impact on how we live, work, interact with the world. They're shaping what we see online, personalizing news feeds, recommending products and services, even influencing our social connections.
It's like they're becoming the invisible architects of our digital lives.
In a way, they are. And while all this personalization and efficiency is great, there are some potential downsides we need to be aware of. For example, there's a lot of talk these days about filter bubbles and echo chambers.
Right, the idea that algorithms can trap us in these little bubbles where we only see information that agrees with what we already believe.
Exactly. And that can make people less open to different viewpoints and perspectives. It's something we need to be aware of as we navigate this increasingly algorithmic internet.
Sounds like understanding algorithms is becoming a pretty crucial skill in the 21st century.
Definitely. We need to understand how they work, what their limitations are, and how they can shape how we see the world.
So it's not about just blindly trusting these algorithms. We have to think critically about them.
Exactly. We need to be aware of potential biases that can sneak in, the ways they can be manipulated, and the ethical questions around how they're used.
It's like any powerful tool, it can be used for good or bad, depending on the intentions of the person using it.
I like that analogy. And just like you wouldn't give someone a chainsaw without showing them how to use it safely, we need to approach algorithms with responsibility and awareness.
So we've talked about the power of algorithms, their limitations, their impact on society. But I want to go back to something you mentioned before, this idea of different algorithms being like tools in a toolbox.
Oh, yeah, I love that analogy. Each algorithm has its own strengths and weaknesses, its own special way of solving problems.
So how does a computer scientist decide which tool to use for a particular job? It must be like trying to pick the right wrench from a giant set.
It can be. It's all about understanding the specifics of each algorithm and figuring out which one fits the task best. Let's say you're designing a system to recommend products to customers on an e-commerce site.
Seems like that's a pretty common use for algorithms these days.
It is, and there are a lot of different algorithms you could use for that. One classic approach is called collaborative filtering.
Collaborative filtering, what's that?
It's based on the idea that if people like similar things in the past, they'll probably like similar things in the future too. So the algorithm looks at your past purchases, compares them to the purchases of millions of other customers, and recommends products that people with similar tastes have liked.
So it's like saying, hey, if you like that book, you might also like this one because a lot of other people who enjoyed the first book also like the second one.
Exactly, and it works surprisingly well. But there are other ways to do it too. Some algorithms focus on the features of products you've liked before to recommend similar items. Others use even fancier techniques like machine learning to personalize recommendations based on lots of different factors.
So it's like having a whole team of personal shoppers, each with their own special way of finding the perfect product for you.
That's a great way to think about it. And which algorithm you choose depends on things like how much data you have, how personalized you want the recommendations to be, and how much computing power you have available.
It sounds like there's a lot of strategy involved in picking the best algorithm for each situation.
It definitely keeps things interesting for us computer scientists. There's always a new challenge, a new chance to explore this amazing world of algorithms.
Well, I've learned so much from this conversation. I feel like I have a whole new appreciation for this hidden world of algorithms that's shaping our lives.
It's been great sharing my passion for algorithms with you and with our listeners. I hope they're as excited about the potential of algorithms as we are. We've covered a lot of ground.
My mind is officially blown wide open.
Yeah.
I never realized just how much algorithms are working behind the scenes in like every aspect of our lives.
It really is a hidden world, isn't it?
Right.
And the crazy thing is, it's a world that's constantly evolving.
Totally. We've talked about ancient algorithms for predicting the stars to super advanced machine learning. It's hard to even fathom what the future holds for algorithms.
I know. But what I find so exciting is that even with all these incredible breakthroughs, we're just getting started with algorithms. There's so much more to uncover.
So there's so much more to explore, more problems to solve, more ways to use algorithms to, make a positive impact on the world.
Absolutely. That's where the real excitement lies. We get to be like explorers, charting new territory in this massive, intricate world of algorithms.
I love that. So, as we venture further into this uncharted territory, what are some of the big questions driving researchers? What are the next frontiers in algorithm development, you think?
Well, one of the biggest challenges right now is efficiency. As we try to solve more complex problems, we need algorithms that can keep up.
Right, we talked about that before. It's pointless to have a brilliant algorithm if it takes forever for a computer to actually run it.
Exactly. So we're always trying to optimize, to find those clever tricks to make algorithms run faster, especially when dealing with massive data sets. And then there's the challenge of making algorithms more robust, more reliable.
What do you mean by that?
Well, in the real world, data is messy. It can be incomplete, inconsistent, even contradictory sometimes. We need algorithms that can handle these imperfections without falling apart.
So it's not enough to design algorithms that work perfectly in a lab setting. They need to be tough enough to deal with the unpredictable nature of, well, reality.
Exactly. We need algorithms that can adapt, that can learn from their mistakes, that can self-correct when things go wrong. And of course, we can't forget about the ethical side of algorithm development, which is becoming increasingly important.
Right, as algorithms become more powerful and more integrated into our lives, we need to make sure they're being used ethically and responsibly.
Absolutely. We need to be aware of the biases that can creep into algorithms, the ways in which they can be misused, and the overall societal impact of their decisions. It's a complex and evolving landscape, but it's one that we need to engage with thoughtfully and carefully.
It's a huge responsibility, but also an incredible opportunity to really shape the future in a positive way.
I couldn't agree more. We have the power to use algorithms to solve some of the world's biggest problems, like climate change, poverty, disease, you name it. But we also need to be mindful of the potential downsides, making sure these tools are used for good.
That's a great point. This has been an absolutely amazing conversation. I feel like I've gained such a deeper understanding of the world of algorithms and how they impact us every day.
It's been my pleasure sharing my passion for algorithms with you and with our listeners. I hope you've all enjoyed this deep dive into the world of algorithms as much as we have.
I know I have. And to everyone listening, keep exploring, keep asking questions, and stay curious about the incredible potential of algorithms. Who knows, maybe one of you will be the next brilliant mind to make a groundbreaking discovery of this amazing and constantly evolving field.